Hey, a farmer owns land which lies between a wall and a hedge. The wall has a length of 50 meters and lies between points O and A. The hedge meets the wall at O, and the angle between the wall and the hedge is 28 degrees. The farmer plans to form a triangular field for her prize-winning goats by placing a fence with a fixed length of 25 meters from point A to the hedge. The fence meets the hedge at a point B. The information is shown on the following diagram. Find the two possible sizes of OAB given your answers in degrees. So whenever a question mentions the possibilities of a triangle, there's two possible triangles, two possible angles. They're anchoring back into the ambiguous case of the law of sines, okay? So find the two possible sizes of OAB. Well, the only way I'm going to be able to do that is, hold on, how do I make this bigger? Okay. The only way I'm going to be able to do that is by setting up a law of sines, okay? So I only have the side length that's across from angle B, so I'm going to have to use angle B in my law of sines. So I've got, because look, across from angle A is like, there's no information, so how can I set up law of sines for that? I have the sine of B is across from the side that measures 50 meters. And then I have the sine of 28 is across from the side that measures 25 meters. So I'm going to make sure that I'm in degrees over here, and I'm going to add a calculator. And I've got the sine of 28 times 50. And then I'm going to inverse sine it. All right, so I've got angle B is 69.87. Okay, so that's one possibility, right? I'm going to find the obtuse version by subtracting 180 minus 69.87, and that will give me the obtuse version of the same angle. So I've got 180 minus this guy, and that's going to give me 110.125. 110.125. So I have B could be 69.87 degrees, or it could be 110.125 degrees. So depending on what B is, that's going to tell me what A is, right? So if B is 69.87 degrees, then we would have to find angle A by doing 180 minus the, oh, hold on, I'm going to put in parentheses, minus the degrees for B and the 28 degrees given in the beginning. So I have 82 degrees left over for A, and that came from angle B of 69.87. So it'd be 82.1 degrees for A, or let's see what happens when we have B measuring 110.125. 110.125. Oh my gosh, I'm sorry. That's the announcement at the end of the day. So I'm going to do 180 minus 110.125 plus the 28 degrees given in the beginning. I've got 41.
Good afternoon, cadets. It is now that time of day.
75 degrees.
PM, so if you're still
So
calling,
angle
make sure you are
OAB could be
if you're staying after school.
82.1 or 41.9 degrees. Okay, those are the two possibilities for that. Next, hence, find the two possible areas of the triangular field. So the two areas are going to come from having a different included angle, right? So I've got one triangle that looks like this, where we have 82.1. Oh, sorry, that was not for B. So we have A, B, O. So B was 69.87, A was 82.1, we had 50, and we had 25. So this is the angle in question here, is like as angle A changes, how does that affect the area? Well, let's find out. So the area is going to be 1/2 A, B, sine of the included angle. And then I'll have another version of the area that comes from B being the larger version, which was 110.125. So that yielded an angle of 41.875 over here, which was now my included angle. So now I've got area being 1/2 50 times 25 times the sine of 41.875. So I would do those in my calculator, and I would get two possible areas. One would be 619, and one would be 417. Okay, so those are my two possible areas. Now it says one of the goats, Brenda, fights with the other goats. Okay. The farmer plans to place a second fence with a fixed length of 10 meters. So it's like this part right here, between the wall and the hedge to form a small triangular field inside OAB for Brenda. The information is shown on the following diagram. The small triangular field OCD has an area of 60 meters squared. So this has an area of 60 meters squared. I feel like that's going to be our clue, right? So let X be the distance OC, and let Y be the distance OD. No, OD is over here, sorry, OD. All right. It says show that x squared plus y squared equals 100 plus 240 over the tangent of 28 degrees. I don't know about you, but it is not clear to me where they're getting these inputs and all this kind of jazz from. So what I'm going to do is I'm going to anchor back into what I do know. And what I do know is that if I'm trying to find a relationship between the sides and the angles, I can either do law of cosines or law of sines. I have all three sides. I mean, I don't know what the numbers are, but I do have representations of all three sides, and I do have the angle that is across from one of the sides. So I'm going to do law of cosines, and then I also have area given as a clue. So that's kind of like the two things I got working on here, or going on here right now, okay? So let's start with the area clue. Where is that? Here's my area clue, and then here, or I guess law of cosines is my second clue. So I got two clues I can work with, okay? So let's set up for clue one, area. So area of the triangle is going to be 1/2 A, B, sine of 28, and then we know that that should equal 60. So I've got 60 is equal to, oh wait, no, my included angle is 28. Ugh, I'm gonna have to use x and y. That's okay. All right, so that's my included angle. So I've got 60 is equal to 1/2 times x, y, sine of 28. Okay, I'm gonna try to like clean this up a little bit, I guess. I'm gonna multiply both sides by 2. I have 120 is equal to x, y, sine of 28. I'm going to divide both sides by the sine of 28. And then I'm going to end up with a representation of x times y. And that's kind of as far as I'm going to go because I don't think I can really go any further than that. So I'm going to stop there. So I've got x, y is equal to 120 over the sine of 28. And I'm actually going to leave it as 120 over the sine of 28 because I see that there's a 28 with a trig ratio over here. And it is tangent, which is not sine, but I feel like something's going to come out in the wash when I do law of cosines because that's going to introduce a cosine for me. Now I got a sine, now I got a cosine, then I get a tan. How you doing, right? So let's set up the law of cosines and see where we land. So I got law of cosines. So I have the side across from the known angle is going to be 10. So the other 2 squared minus 2 times the other 2 times the cosine of 28. All right. I mean, I see an xy here, and I see an xy here, so I'm like, I'm probably going to end up substituting that xy into the other one. I'm starting to see where the 100 comes from. I see the x squared. I see the y squared. Okay, I think we're off to a good start. So I got 100 equals x squared plus y squared minus 2. I'm going to substitute in that version of xy that I got over there. And then I'm going to put this guy over 1. So I'm going to do a little rearranging over here, right? So just like, no, I'll do it the long way. It's fine. Okay, so I got 100 equals x squared plus y squared minus, okay, so 2 over 1 times 120 over the sine of 28. And putting everything as a fraction so I can see if there's anything I can rewrite, okay? So the cosine of 28 and the sine of 28, cosine over sine is cotangent. 2 times 120 gives me 240 times the cotangent of 28 is where I'm at right now, okay? Cotangent is the same thing as 1 over tangent. So I'm going to rewrite it as that because I'm trying to get to a tangent in the denominator. So I've got 100 is equal to x squared plus y squared minus 240 over the tangent of 28. Oh my goodness. Okay, yes, I'm getting there. It looks like I just need to kind of move this guy over to be with the 100, and then I'm good. So I've got x squared plus y squared equals 100 plus 240 over the tangent of 28. Yes, I've done it. Okay. So I showed that x squared plus y squared equals 100 plus 240 over the tangent of 28. Phew! All right. Now I'm going to determine the two possible lengths of OC. This is a calculator question reminder. So I'm going to graph this guy in relation mode. And then I'm going to put the other equivalent representation of xy as my second function. I'm going to see where they intersect, and then that's going to give me my solutions, okay? So that's my plan. Here we go. So I'm going to be in relation mode, and I'm going to type in that is a really small circle. This is trig, right? So I'm going to do menu for zoom trig and see if I can see this thing better. Oh my goodness, I cannot. This is not great. Okay, let's just do, sometimes no, that's not good. Let's do zoom fit. Menu for zoom fit. Okay, that's better. All right, so it doesn't always work, those tricks. All right, so I got something that looks like this. I'm going to draw my picture. So I got x squared plus y squared equals 100 plus 240 over the tangent of 28. Okay, so that's that guy. And then let's add the second one, which is going to be x times y equals, this is the other equation we got, 120 over the sine of 28. All right, so I don't want the negatives because those are negative side lengths. Remember, x and y represent measures and lengths of a side of triangle, so I don't want anything that's negative. So I'm just going to zero in on the positive solutions, and I'm going to find where these guys intersect. All right, so they cross at, I'm going to do my little sketch here. They cross at 13.1 and, hold on, this thing's in the way. Oh, and 19.5. And then over here, it should be the same because it's x times y. I'll show you what I mean, but here you go. It's the same, right? So, except now they're reversed, and I've got 19.5, 13.1. All right, so I have x equals 13.1. Determine the two possible lengths of OC. So x could be 13.1 or x could be 19.5. Okay.